Hello everyone. In today's session, we'll be seeing variables and storage classes in C++. And in order to illustrate the concepts, I'll be sharing a screen where I'll be executing these code snippets. Okay. To begin with, what do you mean by variables? Variables are actually the identifiers are the piece of names which have been given to the memory locations. So how do you declare variables? So in order to declare a variable, the syntax is you need to have the data type specified, means the type of data which you want to be storing in that particular variable, a variable name which has to be given using the rules of an identifier. So this is what is called as a declaration of a variable, where I've just given a data type and a variable name. So if I want to give values to that particular variable, I can actually give it during declaration also. So that is called initialization. So I can also give it as data type variable name equal to value. And in this procedure, I have declared the variable along with initialization also. And if I don't want to initialize it here, using the variable name, I can actually assign value to it. And the values have to be of the same type, which the variable has been declared of. So this particular procedure is called variable declaration and initialization. Now we'll be seeing different kinds of variables in C++ and how do we actually declare them and how can we statically initialize. And this procedure is called static initialization of variables. Why do I call it a static initialization? Because in the code itself, I'm actually initializing the variables. And if I want to take the input from the standard input, that is through the keyboard, I need to be using the IO operations using C, that is using the extraction and insertion operation. We usually do input output operation. So using the insertion operation, we can actually display it to the output screen, and using the extraction operation, I can actually extract the input into my particular program. Okay, so we'll see different kinds of variables which are actually supported in C++ and which we can actually use in our code snippets. So if I want a number, usually a number can be a real number or a decimal number. So we usually have two different kinds of data types for doing that. One is integer, which is used for storing integer variables. And when I tell integer, the compiler actually allocates, if it's a 16-bit compiler, if I'm talking about 16-bit compiler, for integer, it actually allocates 2 bytes of room space. And after allocating 2 bytes of room space, we want to name that particular memory location. So we use a variable name. So I can use num1. So what happens now here is I have declared a variable called num1, which is of type integer. So the compiler allocates 2 bytes of room space for my variable num1, and it gives it a default value. And it will be a garbage value since it is a local variable. If I want, I can actually initialize it to hold a default value. That is, I'm initializing it to hold 7. So now what does a compiler allocates 2 bytes of room for a variable called num1, and it places 7 in it as a value. I can also have a floating type variable declared for storing the real numbers. For example, I'll write it as num2 is equal to 7.2. Okay. So in 16-bit compiler, if I'm talking about 16-bit compiler, and usually theoretically when we explain the concepts, we usually take example of 16-bit compilers. But nowadays the compilers are coming in 32-bit or 64-bit. In 32-bit compiler, integer and float actually have been given 4 bytes of room space because the smallest word length of the system is 4 bytes. And how do we declare a character? So if I have to declare a character, I should use the data type char and a name for the character ch. And characters are actually being initialized in single quotes. So one single character I can be initializing. And if I want string, a collection of characters, in C++, we have a special data type called string. For example, if I have to store name of any person, and if I have to give a default value, I have to give it in double quotes. And I can assign any value to that particular string. And all strings are actually terminated through null character. And if you don't give a null character at the end, automatically the compiler is going to take the null character. And when we are specifying it in the double quotes, we usually don't give null character at the end. It is a compiler implicit placed at the end of a string so as to identify the terminating character for a particular string. So that is done by the compiler automatically. We just have to declare it as string name, and within double quotes, the value which has to be initialized. Now we'll go for displaying these variables which we have actually created. So I'll go for writing the name of the variable and then displaying num1. So in order to know that it is an integer, so we'll also be writing int num1. That is how we actually have declared that. I just have to be writing num1. If you see here, this is just a print statement, which is for my use, so that when I see the output, I'll come to know that, okay, I'm displaying an integer variable called num1. And what's the value? It's been displayed by this particular variable. So if I just run this program and show you. So if you can see here, int num1 is 7. That's what we have actually been given here. So this particular num1 actually displays the value. And this is just a print statement which I've actually given for our understanding. Okay. In the same procedure, if I'll go for displaying other variables, for example, I have float num2. I can do it like this, num2. I'll just insert endl here so that I'll be redirected to a new line, or else the output comes in the same line. So now if I run this particular piece of code, so you can see here, I've got my number being displayed, 7.2. That's because of this particular variable num2. In the same fashion, I can actually go for displaying the other characters. For example, if I have to display the character, so I'm writing ch. We'll do it together. We'll go for string also, displaying the string. So I'll be writing string name and then. Okay. So these are the variables which we have actually declared, and now I'm going to display those variables, all of them. So if you can see here, I've got the integer 7, a floating point 7.2, a character p, and a string called vicky. So these are actually the ways of declaring variables, initializing them, and also displaying them. So now what I've done here is I've done static initialization. So if I want, I can also go for dynamic initialization. So how do I do dynamic initialization? How do I read from keyboard? For example, if I want to read an integer, let me separate these piece of code by just writing a line breaker as star, so that I'll come to know the next piece of output which I can show you. Okay. For example, consider there is an integer which I name it as n, and if I want to read the particular value for an integer, so what I'll be writing here is I'll write a cout statement which has to display telling that enter the value of an integer. So I'll just write enter an integer, endl, and then we have to write cin, and we need to use an extraction operator, that is using the closing angular brackets twice. That actually indicates an extraction operator. It extracts the input from the input buffer through the standard input, given through the standard input, and they just write the variable name. So what it does is it displays the message enter an integer, and it waits for us to enter the integer. So we'll see this. Okay, so if you can see here, enter an integer, and it has to wait for us to enter an integer. But this is an online IDE which I'm actually using. So the way of giving input is a bit different in this particular IDE, CodeChef. So if you're using CodeChef, the way of giving input is, listen carefully, how do we actually give input? There is some option called as custom input here. So I need to be ticking that, which indicates that my particular program actually has an input to be read from the keyboard. Since it is an online compiler which we actually are using, we have a little bit different procedure for providing input. So I'll be giving an integer as 9, and then I'll run the code. So if you see here, there is no change. It has just showed enter an integer. I've given a custom input 9 and no displaying nothing. Why not displaying anything? Because we have not written code for displaying it. Clear? It has successfully taken the variable value 9 and stored it in n. So if we want to see whether it has really stored the variable value 9 in n, so what I'll do is I'll display n. So I'll write n, and then I'll display the value of n. Okay, so custom input is there. So I can change the value. Now I can actually go for giving it a value 91. So what happens is when I run this particular program, first enter an integer, and wherever there is C in, it first takes the value whichever we are given in custom input and places it in n. And the next line I've gone for displaying the value of n. So it should display 91 for me. So I'll just run this piece of code. So you can see here, enter an integer and then n equal to 91. In normal IDEs which you are running in your laptops, if you have an IDE downloaded and running in your laptops like CodeBlocks and NetBeans, enter an integer and the cursor will wait in the next line for you to enter an integer. But since it is an online compiler which I'm using, CodeChef, I need to follow their standards of taking input. So their standard of taking input is through this particular custom input option, where I have to give the inputs in a separate place so that they place it in the location which has been meant for that particular variable or that particular value to be given to certain variables. Clear, right? And in Solo Learn app also, which most of you have been using in your cell phones for executing small code snippets of certain languages, we give input in the same fashion. But in the normal IDEs which we actually use in our laptops, input has to be given in the same place. Enter an integer and it waits for you to enter an integer. The cursor waits for you to enter an integer. And when you give a value, it and press the enter key, because enter key is taken as an end indicator or a delimiter. And in case of numbers, even space is considered as a delimiter. So when you give a space or an enter key, it collects that particular input, whatever we have given, and then places to the variable which has been used for storing that particular value. So this is what is a procedure. And you can also know what is the size of this particular variable n. So I'll be giving that. So we'll write a size of n. What is the size of this particular variable n? We have an operator called as size of operator, and within the parenthesis you need to be giving the variable or the data type whose size you want to find out. And remember, though it looks like an inbuilt function, it is actually a operator. Size of is an operator. So size of is the only operator which comes with an open close parenthesis. All other things in your C and C++, if it comes with open close parenthesis, we actually call it as a function. But size of is not a function, it's actually called as an operator. And it's the only operator which comes with open close parenthesis. So now if I tell, it tells what's the size of variable n. What is the size being given to the variable n? So we'll see. It takes the same custom input, that is 91. Okay, so you can see here size of n is 4. I was telling size of integer is 2 bytes, but that's in a 16-bit machine. But this compiler is actually using a 32-bit machine. So we don't know what's the type of the server which is being deployed for running these online compilers. But since it is using a 32-bit version for storing a single unit, which we call it as a word in our computer, it has showed that the size is 4. In all our modern laptops and systems, whichever is coming, we have minimum size is 4 for integers. Why? Because we no longer use 16-bit machine, 16-bit architecture. We usually use 32-bit or 64-bit architecture, where the minimum word length is either 32 bits or 64 bits. Okay. So this was regarding your variables and how to declare them, how to initialize them, how to go for dynamic initialization of variables, and then how to know the size of the variable which has been given to you. So what is the size what your compiler has given to you? Okay. Now we'll move on to the next concept, which is called as storage classes. What are the different kinds of storage classes available? What are the different types where you can store your variables? So we'll see all the different kinds of storage classes in C++. Okay. To begin with, the first kind of storage classes. For example, if I have an integer, which I'll be naming it as n, okay, and then I need to be giving it a variable value. I'll be giving it as 7. So I'll go for displaying the value of it. Cout n. Okay, so I've displayed the value of n. Then what I'll do here is I'll go for changing the value of n equal to 9, and then I'll use the, okay, and I'll give line numbers so that we'll identify, so that we'll come to know actually we are in which line. Okay, so I have given line numbers so that we'll come to know which line we are actually seeing the output. A simple code where I have a variable n which has been given with value 7 during its declaration. That's the default value which we have given it as 7 during its declaration. And then I'm changing the value of that particular n in between the code snippets, and then I'm again printing the n. So when I run this piece of code, first it displays n equal to 7, and it then displays n equal to 9. So see here. Okay. Now what is the first kind of storage class I can tell you is a const storage class, which means constant variable. Okay, so what do you mean by a constant variable? A constant variable is one whose value cannot be changed, whose value remains fixed throughout the execution of the program. Okay, now if I run this particular piece of code, it throws me an error. Okay, if you can see here, it is throwing me an error. It is telling that your variable n, you have made it as a constant variable. That means it's only read only. I can go for displaying the n, but I cannot go for changing it. I cannot modify it because of this particular storage class that is making the variable as a constant variable. So what happens is if I go for changing the value of the constant variables, it throws me an error saying that you made that particular variable as read-only variable, and now you're trying to edit it. You're trying to write on it. You're trying to modify it. So that's the error which is being created. But if I comment that line, I don't get an error. So twice my n gets printed as 7. Okay, so if you can see here, my n has got printed as 7. So this is what is one kind of storage class, that is making a particular variable as a constant variable. Okay, so we'll go for another storage class. So in this, we have explained about constant storage class. So I'll be just writing a comment line. Constant storage class. Okay, we'll go to the next kind. Okay. We'll see another kind of storage class. The name of that particular storage class which I'm explaining now is called as a static storage class. So what do you mean by a static storage class? Fine. Okay. So let me declare a variable int, okay, and then n. I've declared a variable int equal to n. Okay. For explaining the static variables, I'll take the help of a function. So I'll be writing a function called void function1. Okay, I've written a function called function1 in which I'll be having a variable called n. Okay, and then I'll do n plus plus, which is nothing but incrementing the variable n. And then this n first time I'll go for initializing it with the 1, and I'll be making n plus plus. And then what I'll do here is I'll just print the value of n. So I'll be writing what's the value of n, and then I'll be just printing that particular n. Okay, we don't want this variable n here. So what I've done here is I've written a function which is having a variable n, and I've made it to take the value 1 in its first line, and in the second line I'm incrementing that value, and then I'm printing the value in the third line. So in the main, I'll just go for calling that function 1. Okay. So we'll run this particular program. So we'll be seeing the value of n as 2. Once again, compiler is taking time in running. There is a trouble in your internet connection, so excuse me for that. Okay. You can see here the value of n is 2. How the value of n is 2? First, when I call the function, it goes to the function where I've given n equal to 1, then n plus plus, then it prints n equal to 2. Okay. So what I'll do here is I'll call that function 1 once again. So again, it goes to the function n equal to 1, n plus plus 2. So 2 times n equal to 2 has to be printed. So you can see here 2 times n equal to 2 has printed. Okay, why n equal to 2? Why didn't it store the value of n2 and next time it made it as 3? Because this particular variable is a local variable to this particular function 1. So it goes out of the scope when I come out of the function. So next time when I call a function, it's a fresh copy given it. So it's like a stack. Each time when I call a function, a separate stack is being given to it. There are two different kinds of memory which have been actually given for storing in our computer: stack memory and then our heap memory. Stack memory are actually being given for functions usually, and heap memory for dynamic memory allocations. So what happens is a separate stack has been given for each function call. So for each time a function has been called, a separate stack is maintained. But global variables are stored in the global space where it remains same for all the functions in a program. Okay. So now what I'll be doing here is, you've seen the output now, n equal to 2 and n equal to 2 times if I call the function. So if I call it 3 times, the output remains same, n equal to 2 itself, but it gets printed 3 times because the function has been called thrice. Yes, you can see here, I've got 3 times. Now see the use of the static storage class. So I'll be explaining static storage class. Okay, why do we use static storage class? The static storage class have been used to make variables have global life. Means in order to prevent the variable from losing its scope when it is going out of the function, I can use static storage class. So what I'll do here is I'll just use the keyword static. I've used the keyword static and then I've made static int n equal to 1. Okay, so now let me run this particular piece of code and show you. Earlier it was printing n equal to 2 3 times. Now if you see here, n equal to 2, n equal to 3, n equal to 4. So how did it remember its previous value? That's because of this particular keyword static. I made that particular variable into a global life. The meaning of that is the variable does not lose its scope when it is going out of the function. The variable reserves its scope throughout the program. So first time I call a function 1, n equal to 1. And this particular line is getting executed only once. Once executed in the program. So it becomes n equal to 1 first time, and then n plus plus is 2. So it prints n equal to 2. Next time when I call the same function, it doesn't go to the first line. It directly goes to the second line by remembering the value of n, because n has not lost its scope. So n was 2, so n plus plus is 3, so it prints 3. So next time when I call a function, it again goes to the function, does not go to the first line, go to the second line, and it knows the value of n, that is 3 in the previous function which has got changed. So n equal to 3, 3 plus plus, that is 4. So it prints n equal to 4. So this is your another storage class where you can make a particular variable come to a global space, have a global life. To avoid a variable being with the local life. To avoid a variable going out of the scope when it comes out of its particular function block, we usually use the static storage class. We'll go for the next kind of the storage class. So in order to explain the next kind of storage class, so I need to be declaring a class. And then those we are viewing this video for the first time, what do you mean by class? What is polymorphism? What is inheritance? The video has been already been created in this particular channel and kept. So you can actually view that. And this particular class I'm taking on request, where students wanted to know the little bit basics of storage classes, where they have actually learned the complete C++, but they wanted to revise the concept of storage classes. So I'm using the concepts of class directly here. So let me define a class called A. Okay. And then let me have a variables there. So in the public section, I'll have few variables like int x, and then I'll have int y, and then I can also give a default values to that. That is 1, and then for y, I can actually give the value as 2. Okay, so there are two variables. So what we'll have is we'll have a function void. So for, it's a function of a, so I'll be writing fun a, and this function is just used for printing the values of those two variables x and y. So I'll be using x, then by giving a space, I'll be printing y. Yes. Okay, so if you can see here, there is a class called A. So I need to use a semicolon. It's a syntax of class. And then in my main, I'll go for calling the object of that particular class. So A1 is an object of that particular class. And I'll call the function A1 dot function A. So what it does is I've created an object of the class A, that is A1, and through A1 I'm calling the function A of the class. And since the variables and the functions are public, I can actually access it outside the class. So I have accessed it through the object outside the class. So now I run this particular program and displays actually the values of x and y. So you can see here x is 1, y equal to 2. So what I can do here is I can also go for changing the values of x and y here. So I can make x equal to 1, 1 I'll make, and then I'll make y is equal to 2, 2. And then I'll run the codes. So you can see here x equal to 1, 1, y equal to 2, 2. It has got modified and it has run. Now see the change. If I make this particular function as a constant function, if I make this particular function as a constant function. So what do you mean by a constant function is constant functions cannot modify the data members. So now these two lines are actually modifying the data members. So the meaning of constant functions is constant functions cannot modify the data members, but they can read. As you know, constant variables can only be read. The functions can only read the data members. The functions cannot go for editing the data members. So these are called data members. This is called data member, and we have two data members here, x and y, and this is particularly called as a member function. It's called as a member function. So now if I run this particular code, okay, the usage of const is not here. Void function a const. Sorry. Okay. So you can see here, in a constant member function, I can actually use the variables to display, but I cannot modify them. So it's telling it's a read-only object, and you're trying to change them. So that's a problem for that. So if I comment this particular two lines, then it is not a problem. Okay. So if I run this particular piece of code now, See, I'm getting the output x equal to 1, y equal to 2. The problem comes when I go for editing them. So you can see here, if I go for modifying the data members, then it throws me an error because a constant function cannot go for editing the data members. It can use the data members for reading. It's not writing. So read only access and you're trying to change the value. That's a problem with constant functions. So why I'm explaining constant function is I need to illustrate mutable storage class. Illustration of mutable storage class. So what do you mean by a mutable storage class is if you declare certain variable as mutable. So if you can see here, if I declare this particular x as mutable, then constant member function can also change the mutable data members. That means now my first line is not throwing an error. Why? Because x is a mutable data member. My second line throws an error. If you want to see that, we'll run and we'll see. Excuse me for the slow internet connection. Okay, so you can see here, only y equal to 22 has given me an error. X equal to 11 has not given me an error. Why? Because I made it as mutable. So now if I make my y also as mutable, so now my both data members are mutable data members, so they can be easily edited by constant member function also. So now there is no error. Okay, there is an internet connection problem. So let me run it once again. Excuse me for this net connectivity problem. Okay, so you can see here x equal to 11 and y equal to 22. I could edit, though it is a constant function, I could edit. Why? Because both of my data members are mutable. So that's what is the meaning of mutable keyword. If you make any of your data members as mutable, then even the constant member functions can edit them. What do you mean by constant member functions? Constant member functions are those which are having read-only permissions on the data members. And they are having permissions to edit only the mutable data members. So if I make my x as non-mutable now, that is a general common data member, now it throws an error on x. So if I run this particular piece of code, you can see here, it throws me an error on x. It doesn't throw me an error on y. It just throws me an error on x. So if I comment that x and run, my error is gone. And x remains uneditable in the function and y is got edited to 22. So you can see here, x has stored its value 1 itself and y has got edited to 22. So this is what is illustration of mutable keyword. And mutable keyword comes into an act in case of data members and constant member functions. So I'll repeat, what do you mean by constant member function? Constant member functions are those member functions which have read-only permissions on the data members. And they can edit only the mutable data members. Other data members only have read-only permissions on them in constant member functions. And what do you mean by mutable data members? The data members which are also edited by constant member functions. Okay, so that is what is the concept of mutable storage class. We'll see the next of its kind, storage class. Okay. You don't find any difference in the output when I use this kind of storage class, that is register storage class. What do you mean by register storage classes? Usually my variables are actually stored in a secondary storage. When I'm writing a program, it's stored in secondary storage, or it comes to RAM for execution. When it comes to an execution, it comes to RAM. But what do you mean by register storage classes? I'm requesting my computer to get a special privilege. I'm asking him, can you please store something for me in the registers? What do you mean by register? Registers are memory units. They are inbuilt in the CPU itself. So since they are inbuilt in the CPU, if you store something in the registers, accessing them is very faster, but the size is very small. Actually, if I have to tell the hierarchy of size of storage classes, The smallest storage what you have is register you have, and then you have your cache memory, and then you have your primary memory. I'll be writing PM, and then you'll have your secondary memory, and then you have your networked storage. So I'll be writing network attached storage. Okay. Let me go for writing it completely. Primary memory, secondary memory, a little bit beautifying this line, that's it. So this is what is my memory hierarchy. So register, cache, there are different user levels of caches, like you have L1 cache, L2 cache, L3 caches. So as the architecture and as the specification of the system increases, there are different levels of caches, and cache memory is usually used to fasten the processing speed. And then if I have to tell, I'll be writing it in this box. Okay, I'll be writing in this box. Your CPU is here. I will illustrate it using a double arrow mark. I'll illustrate. So your CPU is here. So as you can see, registers are very near to CPU. Usually they are embedded in the CPU, and then cache, and then primary memory. Primary memory, if I'm telling, it's about RAM and mainly ROM. However, ROM, you're not using it. It's used for standard system softwares to be stored permanently, but we are into RAM. Why? Because any program, if it has to get executed, it has to come to RAM. Or nowadays, directly we can pull it from the cache if it's been regularly used and then give it to the CPU. Or else the normal procedure is usually the memory part will be handled by the computer in such a way that all the programs or whatever we are doing, it's kept in the secondary memory. And when we want to run that particular program, it's been brought to the RAM and then it's been given to the CPU, because CPU has got a clear instruction. If it has to run anything, it has to be from the RAM. It cannot directly run something from the secondary memory. And what I mean by network attached storage is nowadays you've heard about servers for storing and all those things. So you want a network in between, and it is very huge. And if I have to see the size of it, you can see register is very small. Cache is very big compared to register. Primary memory are more than cache memory size. Secondary memories are still more larger space, and server space, it's in terabytes you can get. Clear. Secondary memory, we can tell it's in TBs. If I have to give example of secondary memory, your hard disk drives, which I can tell, and then if I have to quote the size of it, it will be in GB to TB. Correct? Okay, and then primary memory, earlier days it was in MB. And nowadays we have our RAMs coming in GB. And if I have to tell cache memory, it's still most of the time it's in MB. Very rare we find cache memory in GB. Registers are actually in the size of bytes. It's in bytes. So I'll be using B for it. So very small memory. So why I'm telling about memory part here is you have to be knowing memory part to understand this particular storage class, that is register storage class. In a computer, these are the different kinds of memory units what you find. Register, cache memory, primary memory, secondary memory, and network attached storage is not there in your system. It is through an internet you're actually connecting to the server and requesting a space. And then whenever I store anything in my computer, it gets stored in the secondary memory. And if I have to run that particular thing, it then is brought to the RAM. And who is actually monitoring all these procedures? One and only person is your OS. Manages memory. So OS is responsible for bringing someone from secondary memory and storing it in RAM and then running it to CPU. And your CPU is like a person who does not do anything unless until he has been commanded by the operating system. So operating system is actually the boss here, who actually tells what has to come to RAM and when has to get executed. So executing your jobs, storing it in memory, which has to be stored in which place, all those things are actually being managed by operating system, which usually the IT engineers actually learn in their third years of separate subject called operating system. Very interesting subject where it actually tells about how it actually manages the whole computer. anything has to work in a computer, it's through the command of your operating system. Fine. Okay. So now what happens is if I write int a is equal to 7, there is no difference which you can actually find out here. See out, I'll just display the value of a. Okay, so simple. I've made a is equal to 7 and I'm just printing it. So you can see our a is equal to 7. But now if I write int a equal to 7, the whole program, actually my a is actually stored in secondary memory. So now I can request my operating system to give me a space in register. So how do I do it? I should use a keyword called register. Remember, I'm requesting my operating system. Can you give me a space for my particular variable a in the register? Why I'm requesting? So that all my operations with respect to a will be faster. Because if it's stored in secondary memory, first I have to bring it to RAM, then I have to give it to CPU. So it takes time. But if I store it in a register variable directly, then there is no time consumed in bringing it from the secondary memory to primary memory. Directly I can utilize it because registers are inbuilt in the CPU. So this is what is a procedure which has actually been followed. Fine. Okay, now what happens is I'm not sure whether my variable is stored in register, because if operating system feels that no, this particular variable will not have a privilege to be stored in register, it can deny it, then this particular variable becomes a secondary memory variable. Then it will not be stored in registers. So I'll repeat once again. If I write register keyword, I'm not sure I'll be getting a place in computer register. I'm just requesting my operating system, can you give me a space in computer register? Why I'm requesting? So that my operations with respect to a will be faster from henceforth. Fine. Okay. So let me run this code now. You don't find any difference unless until if it has been given in register, and if you do some complex operations, you'll find the difference in time actually. My net connection is taking time, so we'll wait. Pardon me for that. So you can see there is no difference in the output. Output is same. I could not make out what is the difference in the output. So you have to be knowing this particular storage class does not show the difference in the output. It actually shows the difference in the execution time. If at all this particular variable was executed in your register, means if at all this particular storage class was stored in your register. Fine. Okay. So this is what is a concept of register storage class. Let me go for the next one. Okay, so the next storage class is, okay, one more thing which I can tell about your variable is we have a special keyword called auto, where I can directly declare a variable, and if I have to give a value 7. So what happens is, what I mean by auto is automatically defining or taking the type of a variable. So if I write auto a, then I can go for printing cout a 7, sorry, a. Automatically my a is considered as integer now. My a is considered as integer. I have not declared it as integer. Automatically, based on the value what has been given to a, it takes it as an integer. So if I run this particular piece of code, so you can see a is equal to 7. But if I don't initialize it, now if I run this particular piece of code, so internet problem. So let me run it once again. It's an error because auto variables have to be initialized during declaration itself. And I can initialize it to any value. For example, if I take it as 7.2, it gives me 7.2. It default it's to float or double. So you can run this and it will give you the value 7.2. I need not tell what kind of variable it is. I'm not telling about the data type. Automatically, it takes it as a local variable and it takes the type as a value being assigned to it. So this is a special keyword which can be used, which automatically considers the type as based on the value of that particular variable being given. But you have to be very careful. All the auto variables have to be initialized during declaration itself, or else it throws me a error. And you can give it any value. You can give an integer value, you can give a floating point value, or you can also give it a string value or a character value. Okay. So the last concept which I'll be explaining is on the extern keyword, but I cannot execute it in this particular online IDE because it's using the two files which has to be in the same folder or the same destination if I have to run that particular keyword. So I'll be theoretically explaining what do you mean by extern keyword. So what I'll do here is, it is with respect to two different files. Consider this is file 1. I've written this program in file 1. So what is this program doing in file 1 is, okay, so I'll just write it here. So this is my file 1. Consider I'm running two different files, and then I'll write another program in file 2. I cannot show the execution in this online IDE. That's why I'm just theoretically explaining you how actually it works. In file 2, what I'll use is, I'll use a variable int a. I'll use a variable int a is equal to 7. I'm just using a variable int a is equal to 7. Fine. Okay. And then I can have a function here. For example, I'll have void function, and then in that function, let me go for cout a. What's the value of a which has to be printed, and then endl. Fine. I've just written like this. Clear? Okay. And then let me not assign the variable value here. And then in this program, let me have a variable called a is equal to 9, is equal to 9. And then can I call the function fun in this particular program? This function is not defined in this file. The function is defined in another file, but I'm trying to call it here. So if I have to call it, and this variable, if you can see here, it has been initialized somewhere else. So what I can do here is I can use a keyword called extern. So what I mean by this is, this particular a does not belong to this file. It's an integer which is belonging to an external file. So you can see here, it is here. And then this function, what I can do here is I can tell extern void function. What I'm telling my compiler is extern tern. Okay. So what I'm telling my compiler, there is a function called void fun, which is actually an external function. I'm just using it here. So this program, when you run, this is just a file which does not have main, so you cannot run that. But this is a program file which is having actually a main. So when you run this particular program, it actually displays the value 9. How it displays the value 9? When you call this function, my compiler checks where is this function. And by looking into this, it will come to know that, okay, function is not defined here. It's an external function. That means it's defined in another file which is belonging to the same project. So it searches in another file where it has been defined. So it is defined in file 2. So it does the job of file 2. In file 2, if you see, I'm taking a. What is a? A is a variable of integer. And again, a is not in this file 2. A is again in file 1. So it again comes back to file 1, takes the value of a, couts that, and that output you can see in file 1. So this particular concept is called external storage class. So what do you mean by external storage classes? It's by sharing the variables across files. I can define a variable in one file and I can use it in another file. So you can see here, I've defined a variable a in one file. I'm using it in another file, file 2. In the same way, I'm defining a function in one file, file 2, and I'm using that function in another file, file 1. So this is what is the meaning of external storage class. How can you share the functions and variables. And remember, you can only share the global variables. Local variables cannot be shared. You cannot make a local variable with external keyword. You can only share the global variables. That you have to keep it in mind. And this output I'm not illustrating. Why? Because this is an online compiler where two files are not belonging to the same project or in the same location. So I cannot actually run these piece of codes and show you. But if you're running it in code blocks and NetBeans, what you can do is you can run these two pieces of code and keep the files in the same destination folder. And then you can run these programs where you can see the output 9 getting printed. And how it is getting printed? Because my file 1 is taking the support of file 2 for a function, and my file 2 is taking the support of file 1 for the variable A. So extern keyword has to be used in a place where you're telling that that particular variable is not belonging to me, it's belonging to another file. So this is what is a concept of external storage class. So we have seen variable declarations, variable initialization, static initialization. We have seen dynamic initializing through extraction operator, that is seen. And then we have seen how do you find the size of a particular variable using size of operator. And then we have moved on to constant storage class. How do you keep a variable value constant, that is read only. And then we have moved on to static storage class. How do you keep the scope of the variable throughout the program, that is how do you make it as a global scope, how do you avoid it from losing the scope. And then we have gone into the mutable storage class, which comes into act in case of object oriented concepts, that is through classes, where you can make a data member editable even by a constant member function by making it mutable. And then we have seen register storage class, where you don't find any difference in the output, but the thing is you can see the difference in the execution speed. If at all your variables have been given a space in your computer register, then the executions will be way much faster than the normal variables which have been given space in secondary memory. And then we have seen illustration of external storage class. So where I've given a code snippet which I've not illustrated by running it, because I'm using an online IDE. So you can actually run this program in your code blogs or NetBeans IDEs in your laptops, and then you can see that output being displayed, where I can actually share the global variables and functions across the files. So that's the concept of storage classes in C++. Hope this concept was quick refreshing one on storage classes. And in case if you have any queries, you can feel free to write to my mail. prakyat.is@sahyadri.edu.in is my mail ID. So you can write to my mail in case of any queries, and feel free to give suggestions also. Okay. So you can use my mail ID to give suggestions, or also you can also put your queries if you have any queries on the storage classes. And this completes the concept of variables, declaration of variables, static and dynamic initialization of variables, and the various storage classes of C++. So the different storage classes which we have seen here is, we have started with constant, register, static, extern, mutable, and then we have also seen auto, local. What do you mean by auto variables? Which automatically takes based on the value being assigned. Fine. And auto has to be used within a function. Auto has to be used within a function. They're local to a function. Thank you, and any queries or suggestions, feel free to respond.